So the today problem of the day is that we have to find the shortest cycle. So what is the shortest cycle? Let me explain through the example. See, for this example, you can see that the shortest cycle is from 6 from 6 0 5 and 1. This has a shortest cycle length of 4. There is also one more cycle which is of length 5, like 3 2 6 1 and 4. But we have to return the shortest cycle and which is of length 4, which is 6 0 1 and then 5 and then again back to 6. So basically our the problem says this only, that given a graph and edges, and we have to find the shortest cycle among all the cycles which are present in the graph. So how we are going to approach in this question? So basically, uh, so first of all we need to know how can we detect a cycle in a graph. For example, there is a graph like this. So how can we detect a cycle, whether the cycle is present in this graph or not? So for that case, we have to first of all, we can start from any node. Like we start from this node, from this zeroth node. Say, so this is a zeroth node, and we will start pushing. We will use a queue data structure. In queue data structure, we will keep on pushing the elements which are neighbors of the current vertex. Like zero will be for start in the starting. Zero will be pushed in the stack. So the while queue will not be empty, we will run our algorithm. Queue will be pop, and all the its major adjacent neighbors will be put in the stack. Like 1 and 2 will be put in the stack. Let it name them 1, and this is 2. So after that 1 will be popped. So this is a queue, not stack. Like I'm first in first out. So 1 will be popped and its neighbors will be popped, pushed in the queue. So let it be 3. So 0 is already, so we will also mark the visited versus as a visited. So like 0 will already visited, so will not again push it into the queue. So 3 will be pushed. So after 2 will be popped, like here 4 and here like 5. 2 will be popped, 4 will be pushed. After 3 will be popped, 5 will be pushed. Now our queue is having 4 and 5. Now our current element is top of the front of the queue is 4. So when 4 is popped, we can see that its neighbor is 5, which is already visited. But we are also seeing that 4 was not visited through 5, because each other element which was putting into the queue, that was visited by its parent. So we will also keep track of the parent array, because each element which is put in the queue will be put by its parent. But we can see that 4 was pushed by 2 but not by 5, and the neighbor of 4 is 5, which is already in the queue. That means there is a cycle in the graph. So we have to detect a cycle. If there is not any cycle present in the graph, then we'll simply return the -1 as the answer. So like we have concluded how to find the cycle in the graph. But the question is, we have to find the minimum cycle path of the graph. So for this question, like in this question, we can simply return the answer as 5. But what we will do for another question, uh, there are suppose there are more than two graphs in the suppose there are more than one cycles in the graph. suppose let there be 3 cycles in the graph. Now this is the graph, and there are 3 cycles present in the graph. One cycle length is of 3, one is of 4, and one is of again 3. So so if we consider this question, we can see the answer will be 3 only, because the minimum cycle length is of 3. But if we start from this vertex, so if we start from this vertex, we will find a cycle. There is no problem in find a cycle. We will definitely find a cycle. But once we will find a cycle, there is a problem that the length will not be able to find the exact length. So for that case, we will run our algorithm for all the vertices in the present in the graph. Like for one time we will run for this vertex, then for this vertex, then for this vertex, and the minimum answer, we will get the minimum answer when one of the vertex will be, when the vertex from which we are starting will be part of the shortest cycle graph, shortest cycle path of the graph. So for example, when we will start iterating from this node, we will get our answer as 3. Suppose we start our iteration from this node, then we are gonna have our answer as 4, because initially it will find the path over here. It will also find the path over this side also, but that will also conclude the answer as 4 only. So this is the main approach. Like we will be running our algorithm for all the vertices present in the graph. After that, for each vertex, we will keep track of 2 arrays. One is of the parent array, which will be to keep track that that node was who is the parent of the current node, and one will be the distance array, distance of that node from the current node from which we are iterating. So these two arrays will be arrays will be required, and after that we will keep on updating our answer, as answer will be equal to minimum answer or uh, distance of vertex u plus distance of vertex v comma plus 1. So let me go to the coding part. So we can see that this is the overall code. First of all, I have considered a vector of this is the graph. This is basically to make a graph. Then we have put the edges for each vertex. So after that, we are iterating for all the n nodes of the graph. And after that, we am making 2 vectors, one for the distance, one for the parent, and q is created over here. First of all, we push the current node in the queue, and distance of that vertex is equal to 0. While node of queue empty, we will pop the front element of the queue, and for all the adjacent vertices of that popped element, we will check if distance of v is equal to -1. That means that vertex is not visited. So we will update its distance and update its parent also, and push that vertex into the queue. Else, if that means that vertex is already, that means there are 2 possibilities. If the distance is not -1, that means it might could be a parent of that node, or it is already a visited node through other path. So if the parent of u is not equal to v, that means we can say that we have find a cycle, and answer is equal to minimum of answer plus distance of u plus distance of v plus 1. So for after running for all the nodes, we will get our answer, minimum answer, and there might be possibility that answer is equal to int max. Why there might be possible? There is no path present in the cycle. So in that case, we are going to result as an answer as a -1. Else we will return the answer as a minimum answer. So this was the overall code. Let us run this code. So it is passing all the test cases. So this was overall code. So thank you.